In this lesson, we're going to learn how to solve a system of equations with 3 equations and 3 variables. We've already learned how to solve a system of equations where you have 2 equations and 2 variables, and we know that a linear equation makes a line. So when you have 2 of them, it makes 2 lines, and what you're looking for in that system is a point of intersection. Now, an equation with 3 variables describes a whole plane. So that's a little more involved as far as intersection goes. It could intersect in a single point, it can intersect in a line, it can intersect in the whole plane. Now, one example of intersection in a point would be if you look at a cube. If you look at this cube, this corner right here, this is a point where 3 planes intersect. The yellow top, the green side, and the pink side, they all intersect right here in this point. So that's what it would look like if 3 planes, or the corner of the ceiling, that's a sample of a 3-plane intersection. So you can kind of get a visual on it. And there are some others. Now, this is the problem that we're fixing to deal with. And there are 3 equations. I have numbered them so it's a little bit easier for me to refer to equation 1, equation 2, and equation 3. But that is the only significance of these numbers. They're just identifiers. The game plan here is to start eliminating variables because we can only solve an equation that has 1 variable for an answer. And that's what we want to do. What we're going to do is pair these up. That's step number 1. And I'm going to pair 1 and 2 and 1 and 3. You could pair 2, 1, 2, 3. You could pair 3, 1, 3, 2. It doesn't matter as long as you make 2 pairs out of these 3 equations. So let me come over here and write my pairs together, and then we'll move on to the next step. Here are the equations paired up, 1 and 2 and 1 and 3. We're going to work on each separately, but our goal here is to eliminate one of the variables, and we're going to do that just like we did in the solving two equations. We need coefficients to match. Now you can, the choice here, you can pick whether to eliminate X, Y, or Z. You get free choice there. After you pick this time, you have to pick the same letter down here. So you might want to kind of look and see what would be easy all the way around. I'm going to choose to get rid of X. So on this equation, I need a coefficient of 2 here. And it's also easier if you have coefficients that are opposite signs, like positive, negative. That way you can add. If you have the same signs, you just have to subtract, but that's kind of hard for me to keep up with sometimes. So what I'm going to do is I'm going to multiply all the way through on this equation by negative 2. The 2 so it'll match, and the negative so it'll have an opposite sign. Now let's distribute this all the way through. Don't forget to multiply it times your answer over here, the number over here, the constant. Negative 2x. Now, negative times negative 2y is going to be positive 4y. And then negative times that positive z is going to be a negative 2z. And negative times 15 is going to be negative 30. Nothing is going to change on this equation. It's going to stay just like it was, 2x plus 3y minus 3z equals positive 1. Now I'm going to add straight down. My x terms eliminate. 4y plus 3y gives me 7y. Negative 2z plus negative 3z gives me negative 5z. And then negative 30 plus 1 gives me negative 29. Now this is the result from pairing 1 and 3, so I'm going to call it R13. No, it is the result from pairing R1 and 2, so I'm going to call it R12. Okay, the second pairing, which is R1 and 3, I need to eliminate the x's again. Now this one has a positive 4, so to make this have a negative 4 coefficient, I'm going to multiply it times negative 4. And I'm going to need to multiply that all the way through. So our new equation here is going to be negative 4x plus 8y minus 4z equals negative 60. This won't change. So I'm going to have 4x plus 10y minus 5z equals negative 3. And then, just like I did on the other one, I'm going to add straight down. So negative 4x plus negative 4x will be 0. 8 plus 10 is 18y. Negative 4 plus negative 5 is going to be negative 9z. And negative 60 plus negative 3 is negative 63. I'm going to refer to this new equation as R13 because it is the result of pairing 1 and 3. Now when I come back, I've got to clean some space off here. When I come back, you're just going to see this equation and this equation stacked on top of each other because we don't need the work anymore. Okay, here's our new system. We have two equations with two variables, which should be familiar territory now. We need to eliminate, so we're going to have to make something match here. I'm going to choose to make the z's match just because I really don't want to deal with that 18 any more than I have to. So in order to make them match, I'm going to multiply this top equation by 9 and the bottom equation by 5. I'm just flip-flopping these so they'll both have a 45 for a coefficient. Now, once again, these are both negative. So in order to make one positive, one negative, I'll just multiply this one through by negative 9. And that way, they'll be able to cancel out. So when you perform these calculations, you're going to get negative 63y plus 45z equals positive 261. Then multiplying everything here by 5, you're going to get positive 90y minus 45z equals negative 315. Now we're ready to eliminate by adding straight down. Negative 63 plus a 90. Now you got opposite signs, so you're going to subtract and take the sign of the larger number. That's going to leave you 27y equals, these two cancel out, and 261 minus or plus a negative 315 gives you negative 54. Now you have an equation that has one variable, which you can solve using your 4 steps to solving an equation. So divide both sides by 27, and you're going to get y is equal to negative 2. Alright, this is awesome because now we have one letter of the 3. When you solve this, instead of getting an ordered pair, you get what we call an ordered triple. And you're going to put them in alphabetical order. So here's X, Y, and Z. Now we just found Y, so we can put negative 2 in the Y spot. Now that we've solved this, we can take this value up into either of these two equations and fill it in and find the other one. So I'm going to pick this top one. I'll take 7y minus 5z equals negative 29, and I'm going to fill this in for y. So now I've got 7 times negative 2 minus 5z equals negative 29. Negative 14 minus 5z equals negative 29. I'm going to add 14 to each side. This is just your 4 steps to solving an equation. So negative 5z is equal to negative 15. Divide both sides by 5, negative 5 actually, and z is going to be equal to 3. Okay. Now we can come over here. We found z, so we can put 3, positive 3, in that position. Okay. And the last step, let me get us some more room. Now that we have values for y and z, we can go up here and pick any of these, any one of the 3. We can fill in these 2 values and solve it for the remaining one. I'm just going to take the first one because it's first. And I'm going to fill this in for y and z. Now be careful that you're filling in for the correct letters. And then I'm just going to solve it. So x minus 2 times negative 2 gives me negative 4. And that'll make plus a positive. So let me clean that up. Plus 4 plus 3 equals 15. So x plus 7 equals 15. Subtract 7 from each side and x is equal to 8. So there is the third component of your ordered triple. Now if you want to check them, you go back up here and you can fill in all three equations for 8, negative 2, and 3, and you should get a correct answer on all three. Okay, we have a different problem now. Let's expand this knowledge base just a little bit. The first problem that I worked for you, it was already prepared. It was in perfect format, and by that I mean you need all of your equations in standard form, and all of your equations need to have three variables. Now if you look at this new set of equations, all three have a little glitch to it. Well, this one's fine. But these first two, number one, they don't have three variables. This one has an x and a y, this one has an x and a z. And number two, they're not in standard form. So let me show you how to manipulate these. We're going to take this first one. The only thing wrong with this problem is it does not have a z term. So we're just going to insert a placeholder, and we're going to call it 0x because that has no value. Alright? So that's perfectly legitimate. We've not changed the value of the equation. Oops, I'm sorry. This is going to be 0z. 0z. Now, let's look at this one. It is not in standard form, and it does not have a y term, so it's going to need a little bit of work. The first thing I'm going to do is put my y term in there. And we're going to do it the same way we did here. I can put x plus 0y equals this negative 4z plus 25. Now the only thing wrong with it is this z is over here and I need it over there. So I'm going to add 4z to this side and add 4z to this side. And my new equation is x plus 0y plus 4z equals 25. Now I have standard form, and you can see if I moved this one over, my terms would line up. Your terms have to be in the same place in order to eliminate. Okay? And like I said, this one is already in perfect form, so it would line up just right. Now I have a perfectly prepared system of equations. So, just like the first one, what you're going to do is you're going to pair numbers 1 and 3, or 1 and 2, 1 and 3, or 2, 1, 2, 3, which however you decide to pair them up. So you'll go through that whole step-by-step process here. I just want to show you how to prep some equations that were not in standard form or did not already have three variables. Now, the other two things that can happen when you work these problems is something kind of weird. Just like when you had two equations, sometimes you wound up with two lines that didn't intersect, or two lines that were right on top of each other. And that can happen with these too. You can have three planes that are just stacked in the same place, so they're actually the same plane. You can also have three planes that are stacked so that they don't intersect at all. Now what's going to happen there is when you get to the point of solving your two equations, in one case you will end up with something like 3 is equal to 3. If your variable terms eliminate and you get a true statement, then the answer here is the set of all real numbers, or infinite solutions. You can put that. Infinite solutions. Now if you come up with 0 equals 3, this is not a true statement. So your answer to this one would be the empty set, or no solution. Okay? Alright, so you give your problems a try, and I'll try to help you through some of those if you need some help. Okay? Great job, guys.